operations. In these IO operations, we are going to be use one special to handle all those IO data transfer. We are going to use one processor. That processor we can call it as input output processor. Okay, that is IOP is a processor with the direct memory access capability. In this, the computer system divided into memory unit and the number of processor. Each IO processor controls and manages that input output task. The IOP is similar to the CPU except that it handles only the detail of IO processing. This is a IO processors are going to be try to act as a CPU. So we can call it as sometime we can call it as the DMA controllers are going to be act as a IO processor. That's the meaning that the IO processor can fetch and execute its own instruction. These IOP instructions are designed to manage the IO data transfer only. Okay, next. So, for example, we are going to see some block diagram of the IO processor. Here, the memory unit occupies the central position and can communicate with each other, each processor. The CPU processes the data required for solving the computational task. The IOP provides the path for the data transfer between the peripherals as well as memory. The CPU assigns the task of initiating the IO program. The IOP operate independent from the CPU and transfer the data between the peripherals and memory. That is, we can say it like DMA. DMA is one of the IO processor. Okay, so this is a diagrammatic representation. Here, what happened? Here we have the CPU. Okay, here we have the memory unit. In that DMA, what we discussed? This is we discussed DMA controller. The DMA controller is also known as IO processor. For example, here we have the peripheral device, that is IO devices. The IO devices are connected with the IOP. Now, which devices you want to connect it with the CPU or memory unit, that will be decided by the IO processor. All the IO devices are going to give in the request. Depends on the situation, the IO processor are going to be communicate with either memory or CPU. Then after that, the process are going to take place. If it is memory operation, means without the knowledge of the CPU, the IO processor will take care of that. Okay, from the memory unit, then IO processor will take care of the IO operation. That's a diagrammatic representation. Okay, the communication between the IOP and the device is similar to the program control method of transfer, and the communicate with the memory is similar to the direct memory access method. That's I already told you. Okay, the communication with the memory is similar to the direct memory access method, but communicated between the IOP and the device is similar to the program control method. Okay, fine. The large scale computer, each processor is independent of the other processor, and any processor can initiate the operation. Okay, the CPU can act as a master and IOP can act as a slave processor. Okay, the CPU are going to act as a master. They are going to be concentrating the main work. The rest of the subworks, especially for IO operations, task will be given to that IO processor. Okay, the CPU assign the task of initiating operation, but it is the IOP who execute the instruction and not to the CPU. Obviously, it is going to be assigned the task to the IOP. Then the IOP are going to try to execute the operation, not CPU. CPU instructions provide the operation to start the IO transfer. The IOP asks the CPU through the interrupt. Okay, the instructions that are ready from the memory by the IOP are called commands to dismiss from this instruction that are already available in CPU. The commands are prepared by the programmer and stored in the memory. The commands word, okay, the program for the IOP. The CPU informed to that IOP where they find the commands in the memory. Accordingly, the IO operations are going to be try to take place. I hope now you understood what is the role of the IO processor in IO data transfers. Okay, fine. Next, we just go for need for input and output. Okay, so obviously, what's the need for input and output processor? That the input and output interface provide the method for transferring the information between the internal storage and the external IO devices. The peripherals connected to the computer need a special communication link for interfacing them in the central processing unit. The purpose of the communication link to solve the difference that exist between the central computers and each peripheral devices. Okay, the major difference are the peripherals are electromechanically and electromagnetic device, and the CPU and memory are electronic device. Therefore, the conversion of the signal value may be needed. Okay, so that we need to be use the input output processor. The data transfer rate of the peripheral obviously usually that's slower than the data transfer rate of CPU, and consequently the synchronization of the mechanism may be needed. So that is a need for the IO processor. The data code and format in the peripheral devices are different from the word format of the CPU and memory. So to try to convert, we need to go for that IO. Then operating mode of the peripherals are different from each other and must be controlled so as not to be disturb the operation of the other peripheral connected to the